Hello there, Calculus pals, and welcome to our final exam review video. I'm just going to go through kind of quickly and highlight some of the items that I think you might find the most difficult, and then if you have other questions, you can always ask me in class, or send me an email, or tweet at Master and Brown. So our first question, it says an object is moving in a straight line and has a velocity that's modeled by this function. I probably should have given it some units, my bad. Let's do meters per second. On the time interval 0 to 3. Find the time subintervals in which the velocity is positive and those when the velocity is negative. So in this case, the thing we have to keep in mind is that in order to find when my velocity is positive or negative, I have to think about when I'm stopped. So I'm going to set this velocity equal to 0. Here we're happy and excited because this I think is something that factors, question mark. Yep, it would be t plus 5 and t minus 2 would be my two binomials here. And then when I solve, obviously I get two answers, one of which does not make any sense at all, because time shouldn't be negative. So time equals 2 is the spot when my object is stopped. So I begin at 0, at 2 something interesting happens, and then at 3 I'm stopped. So what you can also do now is take numbers in between 0 and 2 and in between 2 and 3, plug them into your velocity and see whether I get a positive or a negative answer. So like if I picked 1, for instance, when I plug 1 into velocity, and it might be easier to plug into the factored version, 1 plus 5, positive number, 1 minus 2, negative number, I get that my velocity is negative in that time interval. And then if I pick a number like 2.5, 2.5 plus 5, yep, positive number, 2.5 minus 2, positive number also. So based on this little sign chart, I could conclude that velocity is negative when t is in between 0 and 2. I don't necessarily mind about whether you have open or closed brackets there. Then for velocity being positive, that's when the time is in between 2 and 3. Again, I don't care about open or closed brackets. Displacement. So displacement is start to finish, how far did I move? We're going to be integrating velocity, and we're looking at each subinterval. So I'm going to have to do this once for 0 to 2, and a second time for 2 to 3. And in the actual test situation, this would be an open calculator question, so you would be able to type this guy in and get a final answer, and that would be totally well and good. So I think on this first one it ends up being negative 11.3 repeating, and then on the second one it ends up being 3.83 repeating. Again, I just got those from typing into my calculator. And if you're trying to tell a story with this, I guess from 0 to 2, I moved I moved 11 spaces like to the left, and then from 2 to 3, I moved like 3.8 spaces to the right. Then it says use a single interval to find a displacement in the whole time interval given. So like from 0 all the way to 3, I'm integrating velocity. And then use a single interval to find the distance traveled. So integrating without absolute value bars, as I'm doing for this first portion of the question, is what allows me to kind of include the fact that negative velocities mean I'm moving to the left, positive velocities mean I'm moving to the right, so a lot of those measurements will cancel each other out to account for that, like back and forth that we might be doing. So I'm really just going to be adding the two answers that I got in part B, and that ends up being negative 7.5, and oh my gosh, I should be putting units on this. Meters, meters, meters. The second part is asking me a very different question. That's talking about the distance traveled. So I want to treat all of my velocities as positive. So really the only difference is that 11.3, I'm going to make positive. And when I add those together now, I get 15.16 repeating meters. I haven't even been doing 3 decimal places. Oh my gosh, slacking. Alright, last one, find the acceleration of the object at the midpoint of the time interval. So step 1, I'm going to have to find the acceleration, aka the derivative of velocity. Step 2, I'm going to plug the midpoint of that time interval from 0 to 3. Right in the middle is 1.5. So that's going to be what I plug into my derivative. And just write my answer here with units, meters per second squared. Sweet. Alrighty. Remember, make this just a regular prime. We've got endpoint. We've got a negative first derivative, meaning our function has a slope that is negative, and that means it is moving down. Meanwhile, from 5 to 7, I've got a function that is going up. When I look at the second derivative and I see negative, that's concave down, concave up. Hint, if the second derivative is 0 for like an entire interval, you're neither concave up nor concave down, aka your function is going to appear as just a straight line. So all I'm doing in part B is kind of combining all those elements together to figure out what this function might look like. So they said from negative 1 to negative 3, I'm decreasing and concave down, so like, what? Then from 3 to 5, I guess I have to be just a line, but I can't be increasing or decreasing on that interval either. And then very last thing, from 5 to 7, I've got to be concave up and increasing, so kind of like the other side of the smiley face. Sweet. Alright, so for number 3, just give you some hints to get started. This is one of those tricky integration by parts problems where, oh my gosh, there's only one thing in the integrand, so I'm going to have to pick that thing to be my u, meaning du is 1 over 1 plus x squared. Spoiler alert, you need to have those inverse trig derivatives memorized still. dv would just be 1, there's the sneaky part, and then v is x squared over 2. When you plug into the ultraviolet voodoo problem, let's see what happens, and I'll give you a tip to finish it off. So u times v minus antiderivative of v du. Ooh, this looks nasty. Oh my gosh, I screwed up. What is this? What is life? The antiderivative of 1 is just x. Ah! Oh. Cool. I did it right over there. When we look at this integral that we're left with, we're like, oh my gosh, this is gross. I still have no idea what to do. So let's think through our list of integration strategies that we know. It's not going to be just regular power rule. Think about whether you could do u sub. I'm thinking u sub may be the way to go. Pick your u to be 1 plus x squared, and then your du is going to be 2x dx, and that x in the top would cancel. I think you'll have a lot of luck there. If having a bunch of u's in this problem is freaking you out, remember you can always do dub sub. Alright. Over on this page, I'm trying to think of some tips or pointers, different things to point out. On part A, first thing that you would want to do is pick u to be not just natural log of x, but the whole natural log of x squared. Then when you take the derivative, remember, chain rule, 2 comes down, leave the inside alone, decrease the power, and then multiply by the derivative of the stuff inside. So there's my du. dv is going to be x, and then x squared over 2 would be v. And probably what you're noticing as you're working on this, u times v would be ln of x squared times x squared over 2. When you look at that second integral, it looks gross. Do things to simplify or sort of cancel things out, like the 2's cancel, one of the x's would cancel. So really what I'm left with is the following. Antiderivative of, let's see, x ln x dx, and that part right there that I'm underlining in green, that's going to be one more IBP, or integration by parts problem. But it's a lot more straightforward and not as ugly as the one that you just did. Part B is also integration by parts, but it's a simple, straightforward one. You could do it in probably 1 or 2 lines. Part C we did in class. Part D, this is one of those problems with a table. The reason that I know that is because I see something that I could take the derivative of and drive it all the way down to 0, and another thing that I could take the derivative of forever and forever and forever. So step 1 is going to be to pick that thing that I can take the derivative of forever to be my, like, u, if you will. So like x to the 5th. Sorry, it's kind of fuzzy. Then the other thing is like my dv, or the thing that I'll integrate over and over and over and over. So I'm going to take the derivative of x to the 5th all the way down to 0. So that would be 5x to the 4th, 20x to the 3rd, 60x squared, 120x, 120, and then 0. Ooh. And then I'm going to do the same number of antiderivatives over on the other side. So something that helps me, I know that 2x is always going to be my argument here. 2x, 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 I know that I'm going to alternate, like, sine, cosine, sine, cosine, sine, cosine. Oh my gosh, this is a nightmare. And I know that I'm going to be kind of alternating signs. Plus, when I anti-differentiate something that has like a coefficient in front of the x, remember that awkward like 1/2 is going to pop out, and then I'd have another 1/2 and get 1/4, and then I'd have another 1/2 and get 1/8, and 1/16, and 1 over 32, and 1 over 64. Oh, gross. The last thing is I'll be alternating signs as well. So like cosine, the way that I get that by taking derivatives is like derivative of sine gives me cosine. That's okay to be positive. But then the derivative of negative cosine is going to get me sine. And you'll notice that you end up alternating like positive, positive, negative, negative, positive, positive, negative. And before I can write out my final answer, yay, remember that when, as far as the signs are concerned, we are starting with like, this is u and this is v. So positive, then negative, positive, then negative, positive, then negative, positive. And I'm going to be multiplying across diagonally. So my first term is going to be 1/2 x to the 5th sine of 2x. And then this minus and this minus cancel each other out, and I get another positive, and it'll be 5 over 4 x to the 4th. Oh, hi, Miss Rodak. Oh my gosh, where was I? Tragedy strikes again. Okay, here we go. Cosine of 2x. Next term is, and I'm not going to simplify these fractions, hashtag lazy, 20 over 8, it'll be negative x to the 3rd sine of 2x, oh, what's the plus? Or sorry, oh, not equals. Minus 60 over 16 x squared cosine of 2x. You'll notice that I'm alternating sines and cosines and my powers are going down. See, almost done. Second to last term, 20 or 120 x over 32 sine of 2x, and that is, both of those are positive. And very last term is minus and minus cancel each other out, so positive 120 over 64 cosine of 2x plus c. And I'm done. Yay! I'm almost done with this one. I'm trying to do one for Calc too. Remember that we changed this problem to be, let's see, x to the 7th, or no, it was going to be x squared, and then the exponent is x cubed. So that's just a u sub. And I just realized too that we changed the problem down at the bottom to not be as evil, but on this 1985 FRQ, main things to point out would just be that if I'm looking for f to have a relative maximum, what helps me a lot is I read f has a maximum. So f is going to look like this. What should the derivative be doing? If my function is going up or has a positive slope versus going down and having a negative slope, I'm looking for the derivative to change from positive to negative. Boom, right there. I was in positive land and now I'm in negative land. So I would write f has a maximum at x equals, what was that, negative 2? Because f prime changes from positive to negative. Yay! And then minimum is very similar. For part B, it says, where is the function f concave up? That's not a prime PS right there. That is just like, you know how they're trying to be fancy with font, I guess. So I'm going to do the same thing. If f is concave up, like a cup, that means f double prime is positive, meaning f prime is increasing. So I'm going to go up here and I'm going to look for the function to be moving upward. So that's like from -1 all the way up to +1. And when I go write about it, I would say f is concave up, not just at one point, but on an interval from x less than or greater than -1 to +1. Again, I don't care about open or closed brackets, because, and I'm going to write my answer in terms of what they gave me, which is f prime. So because f prime is increasing. If you know all those things and feel pretty good about those things, you're in good shape. See you soon.